All right. Hey guys. I hope you're having an awesome evening. I just creating this video for those of you who are going to be gone the next couple of days. We are starting a new section, and that is section 6.2, the natural base E. Okay, so our essential question is, what is the natural base E? And to just kind of get started, E is technically a number, okay? And it's actually a really, really famous irrational number. Okay, we know all about pi. Pi is our probably most famous irrational number that you guys know of. E is kind of an underrated but very, very important number in math, especially for us this chapter. It helps us with logarithms, which is, again, something we're going to get to later on this chapter. Not quite yet, but it's coming. And it was first discovered, I was doing a little bit of research on it. I found a couple of different things. One of my websites said that it was discovered by Jacob Bernoulli, who was a famous mathematician. And the other thing that I saw is that it was introduced by mathematician John Napier. And he used it to develop his theory of logarithms. He decided to use it because it helped him with his common logs, which again is something we're going to get to. But most of the research that you'll find will say that Leonhard Euler, who is a guy that we've talked about a little bit this year, a lot of credit goes to him because he's the one who found out most of the properties of this number. He was the first to use the symbol E. So he's the one who kind of gave it the title of E, and that's really what stuck with it. So that's really why Euler is given a lot of the credit. But I think the first one to actually find it was Napier. But back to Euler, it's kind of funny because he named it E, and a lot of people think that he named it E because of his last name. Euler starts with the letter E, but it actually wasn't. He was doing a lot of research and a lot of work with exponentials, so he kind of meant for it to represent that you were dealing with exponentials when you were looking at the letter E. But another story is that he was using the letter E in a bunch of his other math work, and the next vowel that was available was the letter E. I mean, he was using the letter A for a lot of the work in his other mathematical findings, and then the next letter in his next project was this letter E. So that's kind of a little bit of background on the letter E, or the number E. But it represents, so like pi represents 3.14159, so on and so forth. The letter E has a general number that it is as well. It is 2.718 to 818 to 846. Okay, now it is irrational, so it's going to continue on forever. And it's known so far to about the first million or billion digits. I can't remember. But again, it's just one of those that goes on forever and ever and ever, and it's just never going to stop. If you take a quick look at your calculators, you have a button for E on your calculators. So if you take those out really quick and you just look at it, off to the left-hand side, very left-hand column, you see that second alpha math, x to the -1, x squared. Then you see the log. You also, then the next button, it's like the third one down, and this is on my calculator. It might be slightly different on your calculator. It has e to the x. So it has natural log, or the ln, kind of looks like an I. And then right above it, so you're actually going to have to hit second and then that ln, and e to the x will pop up, or e to the blank square will pop up. So realistically, E comes from this limit that you guys see on the screen here. You're approaching positive infinity when you're looking at E. And the formula that you use is 1 plus 1 over x raised to the x power. But we're going to get into our first couple of examples. Simplify each expression. Okay, so if you notice, every single one of these has the number e to it. And you're going to be using a lot of properties with these three examples. So you're using properties of exponents. Okay, so for letter A, we've got e to the third times e to the sixth. Remember, if we have the exact same base, what we can do is we can take those two exponents and we add them together. So we end up with e to the ninth as our final answer. For letter B, kind of the same concept. We have 16e to the fifth over 4e to the fourth. We're going to break this one up. So we're going to deal with the numbers first. We're going to deal with the e's separately because we know what 16 divided by 4 is. That's going to turn out to be 4. And then dealing with these e's, you've got the quotient property happening here. When you've got the same number and they're just being divided, remember, we're going to take those two exponents and we're going to end up subtracting them. So that would be 4e is what your answer would end up being. Then taking a look at letter C, you have 3 times e to the negative 4x. Okay, so in my mind, the first thing that I'm going to do with this one is I am going to just kind of go through and look at the properties. You've got that negative exponent up there, which is automatically going to take that e to the 4x and bring it down to the denominator. That 3, nothing happens to it, nothing's really attached to it, so you leave it alone. You just let it do its thing up there. But then you've got the entire thing raised to the power of 2. So from here, you basically have to take that 2 and you have to distribute it to all the pieces. So you have 3 squared and you have e to the 4x times 2. So your ending answer will turn out to be 9 over e to the 8x. Okay, so again, like I said, just a lot of properties of exponents so far that you're dealing with. What I want you to do is I am going to show you guys the next few examples that the book has for you. I want you to pause this video and I want you to try these next 3. So go through, just write them out and see how much you understand from the last slide, just with the basic properties. Once again, these properties are really important, so they're going to end up coming back more frequently. But pause the video. I'm going to go through, I'll write up all the answers, and then they'll pop up in a second here. All right, here they are. Hopefully you guys all went 3 for 3. Once again, just a bunch of properties of exponents. Moving on to the next slide. Okay, here we've got just a basic core concept. Talks about the basic shape of the graph of this e to the x. Okay, hopefully it's no surprise to you that this looks and is an exponential growth and decay. So when we write this out, these natural base functions are in the form of y equals a times e raised to the r times x. Okay, that's our natural base exponential function. A couple of things to really look at. If you look at these next couple of bullet points, you have a greater than 0 in both of them. But really the big thing that you want to pay attention to is when r is greater than 0 and when r is less than 0. Okay, when r is greater than 0, that's really what tells you whether you've got a growth or whether you've got a decay. So before, when we were looking at growth and decay, we were looking at the base. When you've got exponentials, you do not have, when you've got these natural bases, when you've got the number e, thrown into your function. You no longer are looking at the base, you're looking at that R value. So you're looking at the number in the exponent that's attached to the x. And then the basic graphs, e to the x is off to the left, that's your exponential growth. And then kind of like we talked about today, if you look, this first point other than 0, 1, that other point is at 1, and then whatever your base is, which for this one you have e, and your number e is 2.718, yada, 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 goes on forever. And then your exponential decay is off to the right, your e to the negative x. So take a second, get this stuff in your notes, really spend some time looking at them and understanding them, because on the next slide, we're going to go through and actually graph a few of these. Okay, so pause the video, go through, look at what you need. Taking a look at the next slide, and I think this will be the last slide for the video. Tell whether each function represents an exponential growth or an exponential decay. Then graph the function. Okay, so a couple of things that we're trying to look at. We're looking at, you've got your 3, and you've got the number that's attached to the exponent next to the x, which right now for this one, so we've got our a value is 3, but then our r value is 1. Okay, so if we look, both of these are positive, both of these are greater than 0. So for this, we've got exponential growth. Okay, so again, with those exponential growths, that's going to go off to the right. Okay, if we just take a quick look at letter B before we move on to the graphing, we will go through and graph each of these. Again, if we look at the A value, this time our A value is 1. There's nothing in front of the E, so there's always a 1. If there's something there, there's always a 1 in front of it. Your R value this time is negative 0.5. Okay, so this time your R value is less than 1. So if your R value is less than 1, then you've got an exponential decay. Okay, now let's go through, let's take a second and just graph each of these. Let me go through really quick and get my graph. That's not what I want. Sorry about that. I want this one. Okay, now since we've got an exponential growth, I'm going to show most of quadrant 1, a little bit of quadrant 2. But the thing that we want to start doing, we don't really know much about E, and E is just a really, really tough number. So we're just going to go through, we're going to create an XY table. Just pick a few numbers. I'm going to pick -2, -1, 0, and 1, just for a few numbers, just to kind of throw in there. If we take -2 and we plug it in for x, right, so we have 3 times e raised to the -2. If we punch that in our calculators, we will come up with 0.41. If we go through and we plug -1 in, so 3 times e raised to the -1, we will come out with 1.10. If we plug 0 in, we will get 3. And then if we plug 1 in, we will get 8.15. Okay, so I'm just going to go through, I'll plot those points really quick. So I'm at -2.41. So a little less than half here. -1 is at 1.10, so a little bit above. Then I'm at 0, 3, and then 1, 8.15. And there you have it. there is your graph for the exponential growth for the 3 times e raised to the x. Okay, now I'm just gonna go through, I'm gonna erase this, I'll use the same graph. You guys should probably create a new one. But I'm just gonna go through, I'm going to use basically the same stuff, but we're gonna move on and we are going to graph this one on the right, this e raised to the negative 0.5 x. Okay, I'm just gonna go through, use a few different points. Let's use -4, -2, 0, and 2. Okay, again, reasons I'm using this. If you look, you've got 0.5. Okay, so even numbers are going to be easier numbers to work with when you take 0.5 times 4 and 0.5 times 2, so on and so forth. So there's my reasoning for that. I'm going to grab this and move it over really quick so I'm at least showing -4. Okay. Again, if you go through and you just do all your little calculations, if you plug -4 in, you'll come up with 7.39. If you plug -2 in, you'll come up with 2.72. If you plug 0 in, you'll get 1. And if you plug 2 in, you'll get 0.37. Okay, so just go through, plot the points, -4, 7.39. We've got -2, 2.72. We've got 0, 1, and 2.37. And there you have it. That is how you go through and you graph your exponentials. So I will post the assignment up on Schoology, so you'll be able to go through and you'll be able to get your homework done. If you've got questions, please come in, let me know. I'm more than happy to answer any questions that you guys have, but I hope you have an awesome weekend and I will see you on Monday.